I know some of them going to do something in 2 hours to get the whole week culminating project done. There are two of them attending the class, taking summer school. They have a culminating project. They're gonna break a record in doing that in 2 hours. They're not gonna show up. That's okay. We're gonna move on. Yeah, I'm gonna go back to the textbook questions. So that's my first step. Hello, sir. Let's see how dedicated you are in doing the textbook questions. All right, so we are in chapter 3. Chapter 1. You have a question in 1.2. Okay, let's go back to the. Oh, somebody's. I don't know. I need to check this. Let's see. Nobody's there. So 1.2. 1.2, 1.2. Yes. Which question is that? Oh. Yeah, 4C. So graph the number line. You cannot, because x is less than or equal to -4. You can only do that. So think about an x. So if you think about a number, the x is always going to be positive number. Absolute value of x is going to be always positive number, isn't it? Do you think positive number ever been is going to be less than negative number? No. But the next one, this is a good one. So Kilman, you're quiet. Did you do the homework question from textbook?
I did 3.1 and 3.3.
Kilman, can
Yeah.
you hear me?
Yeah, I can hear you.
That's kind of weird. He's talking, I can hear. Oh, I see. Oh, my bad. Kilman, can you hear me?
Yeah, I can hear you.
One more time.
Hello, hello.
Oh, Jesus. What's going on? Kilman, you're talking. Why can't I hear you? Okay, try to see what the problem is. Just give me a moment, sir, okay?
Okay.
Let me see Tivia. Tivia, can you hear me?
Yeah, I can hear you.
Tivia also talking. I think that it's probably that. Okay, I'm gonna restart the meeting again. Sorry, guys. I think that my recording, the recording of the meeting is just giving me issue. Hold on. Let's do this. Let's see if iPad. Okay, how about now? Hello.
Hello.
Oh yeah, all good. All pretty good. All right.
Yeah, I said I did 3.1 and 3.3.
Okay, so I'm gonna going back to the question she asked first. So this is the homework question that she said. Find out the solution for this. Oh no, you're not seeing anything here. Okay, can you see me now?
Yeah.
Yeah. Okay, cool. So this is we're looking for absolute value of x less than -4, because you need to know absolute value of x is always a positive number. So there's no way you can have a solution, because there's no positive number. It's going to be less than negative numbers. Make sense? But this one have a solution. So how are we going to looking at it? You're looking for absolute value of x greater than -7. So this is the interesting one. If you plug 1, absolute value of 1 is greater than -7, isn't it? If you plug 6, absolute value of 6 is going to be 6. 6 is greater than -7, isn't it? If I plug 7, absolute value of 7 is 7. 7 is greater than -7, isn't it? If you plug -7, absolute value of -7 is 7. 7 is greater than -7, isn't it? Are you seeing that? So this is the solution for this. X belongs to real. Because if you plug any real number, absolute value of the real number is going to be positive number. All the positive number is going to be greater than negative number, isn't it? Okay, Divya, do you have any questions from the homework?
No.
Okay, so Divya had done all of them. So let's going back to Tillman, who has questions from which one, sir? 3.1, which section, sir?
It's page
Page
129
129.
where it started.
Page 1. All right, so you go by the page 129. So, okay, so polynomial function.
127, my bad.
You say 127. Okay, which question, sir? 127. Yes. Yes. Which one? Sir. What's happening? I'm not hearing his talking. Kilman, which question?
Oh, my bad. I was muted. You take a look at question 4.
All right, so you're looking for question number 4, this one. Graph the function, explain why a person who sees only the graph you created, not the equation, might think the graph represent a polynomial function. Explain why this function is not a polynomial function. Cool, that's cool. That's a good question. So let's going back. Tivia have done all the questions. Tivia is going to answer the question. So Tivia, going back to this question from the textbook, what did you respond? How did you respond to that question? Tivia,
Yeah.
what did you say? Explain why a person who sees only the graph you created might think the graph represents a polynomial function.
Because it has two x-intercepts.
Has two x-intercept. What x-intercept?
Like the polynomial function I created.
But you're creating a graph of y is equal to 2 to the power of x. So where did you get that x-intercept here? It's an exponential function. Does it have any x-intercept? Did you do that question?
I think so.
Did you check the answer on the back to see it makes
No.
sense? All right, so I'm going to sketch this graph first. So y is equal to 2 to the power of x. We are creating a graph in the interval x is equal to y is equal to 2 to the power of x go from 0, 1, 2, 3. 2 to the power 0, 1, 2, 4. This is going to be 8, isn't it? So I'm going to plot that point. This is 0. Then this is 1. So that's the first point. And 1, you got a 2. And then 2, you got a 4. So 2, you got 4. So if you're going to connect this, when somebody seeing this graph, they're going to say this is a quadratic because this is look like a quadratic function if you see that. Now, explain why this function is not a polynomial function. So now we need to say why this is not a polynomial function. So we can prove that by taking the ratio between these two. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. What that tells us, this is going to be an exponential function because the ratios are constant. So for the part B of that answer, you can see common ratios are, the ratios between let me close this door and come back. Even I close the door, I think that I can hear that sound, I believe. All right, so we're gonna moving back to the next question. This is coming from Kilman. Kilman, do you have any questions, sir?
No.
All right, so Kevin, what are your questions? Textbook 3.2, question number 6. Okay. All right. All right. So this is asking even an example of a polynomial function that's following the property. Remember, there are 4 types of polynomial functions. So first polynomial function, open for the second quadrant, go into that first quadrant. Next polynomial function, open from the third quadrant, go into the fourth quadrant. Next polynomial function, open from the third quadrant, go into the first quadrant. Next polynomial function, open from the second quadrant, go to the fourth quadrant. This polynomial function has when x goes to plus or minus infinity, y goes to positive infinity. This polynomial function, x goes to plus or minus infinity, y goes to negative infinity. This polynomial function, x goes to positive infinity, y goes to positive infinity, x goes to negative infinity, y goes to negative infinity. this polynomial function, x goes to positive infinity, y goes to negative infinity. When x goes to negative infinity, y goes to positive infinity. This is the function odd degree polynomial, even degree polynomial function, leading coefficient positive, even degree polynomial function, leading coefficient is negative. Odd degree polynomial function, leading coefficient is positive. Odd degree polynomial function, leading coefficient is negative, which we talked about last class. So let's going back to what they're looking for. X goes to negative infinity, y goes to negative infinity. X goes to positive infinity, y goes to positive infinity. Now we can see that when x goes to negative infinity, y need to go to negative infinity. When x goes to positive infinity, y need to go to positive infinity. It can be any polynomial function has the highest degree to be odd. Now you should be able to answer the rest, isn't it, sir? So this is a summary we talked about last class. You need to know. Even degree polynomial function with a leading coefficient start from quadrant 2 to quadrant 1, x goes to positive infinity, negative infinity, y goes to positive infinity. Even degree polynomial function with the leading coefficient negative will go to when x goes to plus or minus infinity, y goes to negative infinity. So those are the four shapes you can see: up parabola, down parabola, a snake, and a snake. Okay, what is your next question, sir? In chapter 3. Families of polynomial function. We're gonna go back to that today. So we're not quite finished that lesson on that 3.3. So when I finish this lesson for today, you should be able to see the families of polynomial function, which is coming soon. Families, symmetry in polynomial function. I'm gonna go back to see if I have the families of polynomial function, and I'll show you what a family of polynomial function at a moment. So let's other than that, do you have any other question on 3.3? We will talk about families of polynomial function. All right, we're gonna going back to the handout. So we're gonna going back to see how we should be able to sketch these graphs. Do you have the handout? Okay, so degree. This is interesting. Let's start from Hillman. What is the degree of the polynomial function, sir?
Is it 2?
Okay, man. There's a 2 here, there's a 1 here, it's gonna be 3, isn't it?
Or 3?
Leading coefficient, Divya. I mean, yes, Divya, leading coefficient.
-2.
-2, right? Because in front of the x you got 1, in front of the x you also got 1. So 1 squared is 1. So if you multiply all of them, -2. Now we're going to talk about end behavior. Degree 3. Leading coefficient is negative. When x goes to positive infinity, y will go to. So this is how I do this time. When x goes to positive infinity, y goes to negative infinity. When x goes to negative infinity, y goes to positive infinity. X-intercept. We can clearly see. Let's going back to other way. What are the x-intercept? Correct. X equal to 1, x equal to -2. I will rewrite them by just simply write x-intercept are x equal to 1, -2. Y-intercept, Kevin, what is the y-intercept, sir? So he said -4, correct, because if you put 0 here, -1 whole thing squared, times it by 2, times it by 2. And then there's a negative in front of it, -4. So we have to sketch it. So watch it how we're gonna sketch it. First step, we're gonna mark the intercept. 1 and -2, 1 and -2. Then I'm gonna mark -4. Okay. Now something we need to know, we talked about last class. When the 0 or the x-intercept have an even number, the graph bounces. So what's going to happen when the graph bounces? So the graph is going to be start from here, and it's going to be go through here, and then need to turn through here, and then has to bounce in here and come back, and come back. So where is the bouncing happening? You can see that bouncing happening at x equal to 1. That's an important point. So why it is bouncing? Because the order of the 0 is 2. Even, isn't it? Hillman? Are you following that, sir?
Yeah.
Shape of the curve. Okay. So we need to move back to the next one. So I'm going to show you various graphs to practice drawing it so that you should be able to draw the graph by yourself. So let's go back here. Degree, other way. Correct. Degree is 4. Leading coefficient, Kevin. That's not true. What? That's not true, sir. Let me talk about it. You got a negative here. You see this too, isn't it? You're cubing that. You take the leading coefficient every single binomial, apply the exponent. So -1 time, -1 time. This is 2 cubed, and this one 1. So that is going to be -8. You're seeing that? Because when you doing this, think about this. This is 2x plus 1 time 2x plus 1 time 2x plus 1 times x minus 3 times by negative. You know how did you get your first term? 2 times 2, 4 times 2, 8 times 1. Are you guys following that technique here? Leading coefficient is -8. Divya?
Yeah.
Okay.
Wait, so I have
NB.
a question.
Yes, sir.
So if it was like, let's say it was like negative in brackets, like 3x plus 1 and it was squared, so then your leading coefficient would be -9?
Correct. You got it.
Okay.
That's right. So you had to take the leading coefficient of every bracket and then apply the exponent,
Okay.
right? Okay.
Yeah.
Here we are, the right. Mm-hmm. Okay.
When x plus c negative followed to
How come? This is even degree, leading coefficient negative. You have to have a sketch, something represent there, and a parabola upside down. When x goes to plus or minus infinity, y goes to negative infinity, isn't it? All right. Now, Kevin, what are the x-intercepts, sir? -1 or 2. Now, y-intercept, Kilman.
Sorry, my mic was muted. It's 3.
Correct, yes. Because if you plus 0 here, plus 0 here, -3 times -1. So we're going to mark all the information. So first we got a 3. Then we got a -1/2. Cool. Then I got y-intercept 3. I didn't really like that. So the graph, so 3 is somewhere, the scale, I don't like the scale. So I don't like the scale. So what would I do for my scale? So let's go keep the scale by 1. Actually, let's chop all the zeros, okay? So the scale is going to be going by 2, 4, 6. So 2, 4, 6, 8. So I want 3, so y-intercept. Now let's see how the graph is going to look like. So this is where things get interesting. So watch this. So the graph is going to start somewhere here. The graph is going to start somewhere here. But remember, there's a 3 here. We talked about the 3 last class. The 3 will make the graphs goes like that, an S shape. So when it's come to that 0, it's going to go like that and go here. Go here. Now, after that, it goes to negative infinity. So he has to come back again and go through here. Do you guys see the picture? Hello.
Yeah.
Hi. So that is the shape that I will be marking to see you got it right. And then the next one I'll be checking you got that right. Next one I will be checking this one. So that's a 1, 2, 3, 4, 5 marks for the graph, or 2.5 marks after you fill out a table that's showing the key point. So let me show you how the graph will look like on Desmos so you can get the picture. So y is equal to -2x plus 1 to the power of 3 and x minus 3. So let's going back to my Desmos to grab a Desmos graph. So y is equal to Do you see that? The only difference is it goes further to turn it. I show you turning it quite a smaller point, but do you guys see the shape of the curve? A shape going
Yeah.
through here. So the only thing is right now it's going further because of the exponent. Nobody's going to be scared about that part. You can show that little turn. It'll go further and turn. That's fine. So this is going to be go turn like that. So that's a better way to show it rather than turning there. Let me see. All right. So moving back to the next guy. Now we will be in trouble. Why we will be in trouble in drawing this graph? Let's going back to asking that to Divya. What do you think the problem here to draw this graph, Divya?
Should you factor out an x?
Yeah, well, it is not in factored form. So we had to completely factor it. So we can take x squared as a common factor, x squared minus 4x plus 3. We're not done yet. We have to factor that further. X squared, that's going to be x minus 3, x minus 1, isn't it? All right. Kilman, what is the degree?
4.
Leading coefficient?
1.
So x goes to plus or minus infinity, y goes to positive infinity. Very easy to say the intercept. Y-intercept, so if I plug 0, it's going to 0, right? So let's show you how that's going to graph. So it's going to go through here. And then there's a 3 and 1 here. Now, if you look at here, leading coefficient is positive. The graph is supposed to start from here. It's going to come back and bounce in here, and then it's going to be go through here. It's going to go through here because it's need to come back. After bounce, it's going to go through here. Then it's go through here, because the rest of the zeros are at 1, isn't it? Uh-oh. Hi. Are you seeing that picture? Guys, online folks.
Yeah.
Yes.
Okay. All right. So we're gonna moving back to the next question. I didn't see your sister yesterday for physics class. Is she forget to wake up?
Yeah, I think so.
Okay. All right. Now we're going back to represent the graph of polynomial function in an equation. So here's what you guys are gonna do. Y is equal to factored form. We don't know the a. First find the first zero. What is the first zero? -2, isn't it? X minus 2. What is the shape here in that zero? Bouncing, isn't it? Bouncing mean you will get an exponent too. All right, what is my next zero? At x minus 3. My next zero as 3. X minus 3. Is that x minus 3 what's happening? Bouncing again, isn't it? So therefore, a into x plus 2 times x minus 3. Now we have to find the a. How do you find the a? We have a 0.2 comma 4. So if I substitute that, a into 2 plus 2 times 2 minus 3. So 4 is equal to 8 times 4 times minus 1. Cancel. A is equal to -1. That's
Wait,
not the right answer.
what about the squares?
You're right, sir. You're right. So that's why I try to go back to my answer, because I know the shape of the graph doesn't match with my a value. So a is equal to 1. So therefore, is going to be x plus 2 whole thing squared times x minus 3. Make sense? Hello?
Yeah.
Now, families of polynomial function. What does families of polynomial function look like? So they have the same x-intercept. I mean, they have the same zeros. So I can have the same graph going like this, going like this, bouncing like this, bouncing like this, going like this, going like this, bouncing like this. You see that? So families of polynomial function, they will have the same x-intercept. Make sense? That's,
I have a question.
yeah.
Isn't 4 squared supposed to be 16?
You're right. That is 16 because I didn't apply what he suggests. So that's 16. So correct. That is going to be 16. So that is 4 times a 16 times 1. A is equal to 1/4. So 1/4 in x plus 2 whole thing squared x minus 3. Right? They are another families of polynomial function. They just need to have the same zero. So they can bounce in here, 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 bounce in here. This is also families of polynomial function. So when the question is asking for families of polynomial function, like grade 11, they simply have same x-intercept, but they can have different y-intercept. Are you just following that question? How do we get this one done? Kilman,
Yeah, I got it.
Xavier.
Yes.
Again, next, show you how to do the next one. Description is given. Always start from a degree 4 with the zeros, order 3. X minus 1, order 3. And 1. So zeros with order 3 and 1. So that is going to be x minus 1. And with the y-intercept of -2. So this is the first setup. The order 3 tells what the exponent we should put. Now we had to work with y-intercept of -2 means 0, -2. So we're going to find the a. Can you just find the a? Tell me what you guys got. Find the a and tell what did you get for a. Pretty straightforward. What do you get? So a. The right. Negative. So -81 times x plus 3 whole thing cube times x minus 1. Let's see other is right. So this is -2 when x is 0. So that is going to be 3 cubed times -1. So -2 is equal to 8 times 3 cubed is 27 times -1. So a is equal to 2 over 27. Right. Said what you get, sir? Are you guys following that, guys? Hello.
Yeah.
Hello. Okay. All right. Go. So before I going back to the next one, we have to do some practice. So let's do this. All right, ready? All right, so let's go. Select all of the following expressions that is polynomials. You're gonna tell me which one I need to check. So let's ask Kilman. Kilman, You can say first box, second box, third box, fourth box, fifth box, sixth box. I can check it.
Third box.
You say third box,
Yeah.
okay, and then
Oh yeah, I should give all of them.
sorry, all of them.
Wait, do you want me to give all of them?
Correct.
It would be, wait 1 second. It would be 8x to the power 2.5, the first box.
Okay, first box.
The bottom one.
The last box.
Yeah.
That's it.
Uh, the 2.5x to the power 6. I think
What
that's it.
else? That's it.
Uh, oh, the
So,
9x one too.
sorry.
The 9x, the second one.
All right. That's it.
Wait, are all of them polynomials?
I'm asking. Yes, you have to tell me which one are
I
polynomial
think
functions.
all of them are polynomials.
Also, just put all the check mark here.
Yeah.
Where were you, sir, during my lesson last class?
I don't know, I was here.
Huh? Watching your soccer game or basketball game, playing your basketball
Nah.
game. They're not all polynomial functions. So that is not a polynomial function because it's a sin x term. The second last is not a polynomial function. It have x to the power of half term. In a polynomial function, coefficients can be anything. The exponent for the x must be positive integers. That work out. This is not right. Exponent must be positive integer, cannot be a variable. Next one right. This is not right because exponent must be a positive integer. Are you following that, sir?
Yeah.
All right. Continue. I don't really want to see the solution. All right. Match the function that's corresponding in behavior. So I'm going to pass this to Adurai. So Adurai, you can take my iPad and then fill out the solution so people can see it. So, okay. Okay. So do you need a match with the in behavior? And then you put submit. Probably got the right. All right. You can drag it to join the puzzle.
Yeah. Yes, it's-
The mono line. Click submit. Correct. So let me show you how to fix it. Okay, so let me pass to here. See if you understand that, what's going on. Try again. Or you had to just move around to try again. I guess can you find out how to there's a four type of curves you do remember. Even degree polynomial function leading coefficient positive, even degree polynomial function leading coefficient negative. So the first one is a parabola open up, second one is parabola open down. Then you can imagine about the S shape or the snake shape. So draw that on a piece of paper and then look at it. So even with the leading coefficient positive, pointing upwardly. So another way to remember, if Doesn't matter where x goes to. If y is going to the same, then it should be even degree. So positive mean if I go to positive infinity both direction, even with the leading coefficient positive. Otherwise, even with the leading coefficient negative. Take some so if you get it right. Okay, he changes mind. Changing his mind, not to have a discussion with just wait. Okay, I'm gonna be just that. All right, I'm gonna try again to show you what is the answer. Try again. All right, guys. So let me take these ones out. Okay, so x goes to positive infinity, y goes to negative infinity, x goes to negative infinity, y goes to positive infinity. So you have to visualize it. When x goes to positive infinity, y goes to negative infinity, right? When x goes to positive infinity, y goes to negative infinity. And x goes to negative infinity, y goes to positive infinity. Out of this, if y doesn't go to the same infinity, it should be an odd degree polynomial. But now you're going to visualize it. X goes to positive, y goes to positive, mean leading coefficient is positive. Okay, x goes to positive, y goes to negative, leading coefficient is negative. So that's very much with this guy. This is when x goes to positive, y goes to negative, y must goes to positive. So you got this. When x goes to positive, y goes to negative, that should be this. And this one, x goes to positive, y goes to positive, and x goes to negative, y goes to negative. Oh, what is this? Which one I didn't choose it correct? Let me double check this. Hi there. Let me double check this. Okay. Which one I'm matching is not x goes to positive, y goes to negative, y goes to negative. That should be correct. That's much correct. To skip the solution, select. Okay, negative 2x cubed. When x goes to positive, y goes to. When x goes to, oh, I see. When x goes to positive infinity, y goes to negative infinity. When x goes to negative, oh, yes, that's right. Let me see any catches there. Oh, yes, there's a catch. There's a big catch. I like this question. I will do that again. You guys gonna see. Try again. What's the big catch? Okay. If you see that third one, the leading coefficient is negative. It's an even degree. They didn't write them in increasing or decreasing order. So this is going to be when x goes to negative infinity, y goes to positive. When x goes to negative and positive infinity, y goes to positive infinity. What I'm talking about. When x goes to plus or minus infinity, y need to go to negative. When x goes to plus or minus infinity, y need to go to negative is belong to that because its leading coefficient is not 3. It's 4. Did you guys see the problem? Hello. Hi. Guys, did you see what the trick there? The x to the power of 4.
Wait, can you explain it again?
What is the leading coefficient on that polynomial, sir?
4. Oh, I meant
Leading
or no, wait.
-7, correct. What is the
7.
degree?
4.
What is the degree? So what's happened was I was looking at it as an x cubed. That's a first term, but it's not the first term. First term is the leading coefficient, right? So I didn't realize they didn't rewrite that question in increasing the degree. They switch around the x to the power of 4x cubed. So that was the mistake. So now we're gonna go back to the next even. So this is leading coefficient is x to the power of 4. So that's correctly matched. Now this one minus 2x cubed. So x goes to positive infinity. Y need to go to negative. This one, something. Oh, that is x cubed. So leading coefficient is positive. When x goes to positive infinity, y goes to positive infinity. When x goes to negative infinity, y goes to negative infinity. So that's correct. So x goes to positive, it goes to positive, negative. So this is correct. So the catch here is x to the power of 4 sitting on the middle. Is a very nice question to put on a multiple choice because you will always looking at the leading coefficient to be the first one, isn't it? Are you seeing the picture?
Yeah.
All right. So, Divya, we talk about this. You're going to tell me what to choose. So the first one, for the polynomial function with the odd degree, the ends have same direction, opposite direction.
Uh,
The ends goes on the same way. That means open upward,
oh,
open.
yeah, same direction.
So odd degree function will have same direction.
Yeah.
So you need to understand what that means by same direction. The end have same direction. So when x goes to plus or minus infinity, y goes to positive infinity. This is the same direction for even. But if you look at this, if you look at here, the n, are they going the same direction? They're going the
Mhm.
opposite direction. One goes here, the other one goes here, isn't it?
Yeah.
Why do you say that same direction? So the ends mean the end point, are they going towards the same direction or they going the opposite direction? So if you look at an odd degree, the end, are they going the same direction? One
No.
go to Ottawa, the other one go to India. Okay. Now I'm not going to tell what to fix it, so I'm going to say opposite direction. Okay, the maximum number of 0.
More than one.
I'm not going to say, I'm just going to say more than one. Okay. The minimum number of 0.
One.
All right, maximum number of turning point.
Um, 0.
The minimum number of turning point.
Wait, I meant 0 for this one.
You mean 0 for that? Okay, so what should I choose here?
One more than the degree.
So here I didn't get any one of them right. Oh, I mean one of them right because the first one I said is correct. That's how I did it. So the maximum number of zeros for any polynomial function is going to be the same as the degree. The minimum number of 0 is for our odd degree polynomial function is 1 because it has to cross the x-axis. The maximum number of turning point is going to be 1 less than the degree. The minimum number of turning point for odd degree polynomial can be 0. So why is the case? Look at that odd degree polynomial function. Why are they talking about turning points can be 0? Because it doesn't need to turn. Just cross the x-axis. Minimum it should need to cross the x-axis at 1 point. But it doesn't need to turn, isn't it? We talk about the summary last class. All right. Are you just following that? Hello?
Yeah.
Audrey. Even degree, what should I choose? Maximum number of 0. Minimum number of 0. Number of turning point. Minimum number of turning point.
Um,
0, you said? Oh, here the answers, yeah. So out of that, I got one of them right, the rest is not right. The maximum number of 0 for any polynomial function is going to be equivalent to degree. The minimum number of 0 for an even degree polynomial function is 0 because it doesn't need to cross the x-axis. Can be sitting above the x-axis or below the x-axis, right? The maximum number of turning point is going to be always 1 less than the degree. The minimum number of turning point, the quadratic function has to turn at 1 point, minimum at least 1 point. We talked about this last class. Think about I'm putting this as a test question, pen and paper test. 5 marks, 1 marks each, 10 marks. And then matching one, another 4 marks. All right. You had to be confident on this topic. So otherwise, all right. So now the graph of the degree 6 polynomial function is shown. Drag each exponent to match it. Divya, what should I put on the first? What should I put on the first box, Divya? 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 Okay, Divya is not here. Okay, going back to Kilman. What should I put on the first box, sir?
Square.
First box, he said, drag and drop the square. All right, cool. What should I put the next box, man?
The 1.
He already said the right answer here. Why should I put a third box? Of course, I should put 1. Correct, because x minus 1 bouncing, x plus 1 snake it, x minus 2, x minus 2. Oh no, who said that? So something is not right. X minus 2.
I'm
That
pretty sure
should
x
be
plus
the.
1 is like 1
Oh,
and x
yeah,
minus 2
x.
3.
All right, this should be 2. So let's move around things. You guys are doing that. X minus 2 bouncing. X minus 1 is a snake. X plus 1 is going through. Please try again. Okay, what did I do wrong? Let me double check this. X minus 1. Oh, why did I put 3? It should be for the minus 1. So this to be switched around. Try again. This should be switched around. All right. X minus 1 going through. You can see that it's going through. Next one. X minus 1 here, when the 0 is minus 1, it's where the snake is, which is 3. X minus 2, I mean, x is equal to 2, it's bouncing. Are you seeing the picture?
Yeah.
Kevin? All right. Continue. My next question. All right. Sketch the graph of that polynomial. This is the annoying part. So the problem with this is I need to zoom in each graph to show you. So you guys gonna be looking at the graph. So I want you guys to do a rough sketch on a piece of paper. Can you guys do a rough sketch? Rough sketch of the graph on a piece of paper. If you have a grid notebook, use a ruler, draw an axis, and then graph it. All right. The only thing I can see. So you guys going to be sketch the graph. Kilman, you can send me the picture of the graph, rough sketch. And I want to see how the graph look like from these guys first.
Okay.
All right. Let me see the shape of the curve, sir. So this one has to bounce because it's even. Makes sense? Okay. There's one more thing that you didn't start correct either, because the degree is the leading coefficient is negative, isn't it? So it should be same graph. It's going to be other way around. Okay, let me see. How do you sketch that? All right, you have to have the rough sketch of the curve. So let's going back to Devier. What is the degree of this polynomial?
Is it the last graph?
You say this is going to be the last graph. Okay, so she just looking at it. Leading coefficient is going to be negative, so it's going to be open downward. She is right on that sense. And then she's just looking at the graph to see that it's going to be have a snake shape at 1/2. Unfortunately, it doesn't have the snake shape at 1/2. So if you look in here, we don't have the snaky shape at 1/2, because if I go going back, this is the 0 is 1/2. So you have to have a snaky shape in 1/2. So let's going back here. Do you have a snaky shape in 1/2? Yes, I do. Does this open downward? Yes. Is it bouncing at 4? Correct. So let's moving back to further. It should be have an x-intercept is -3. So it has an x-intercept is -3. It has a bouncing at 4. Correct. And then have a snake shape in there. That is correct shape. So let's look at these guys. This one, no snake shape. So I can ignore that. This one, I do have a snake shape, but that open upward. Makes sense? Hi. Are you guys following that shape of the curve?
Yeah.
Guys, are you seeing the shape of the curve? Open downward. Because the leading coefficient is negative. Then we're looking at all the important properties to answer the question. All right, that's fine. All right. The degree 6 polynomial is shown in the graph. Determine the function. So I'm going to give you guys the time to look at it. Look at all the information there, and then tell me which choice, A or B or C or D. Certain choice you can ignore easily. All right. Kevin.
I made a conclusion that the first one is not an answer.
Correct. Okay, he said first one is not right answer. What are the possible answers here, Sadre? Which one of them can be? How about the second one? Isn't exactly the same x plus 2 whole thing squared x minus 1. So now we had to tell what's the A values, right? So look at the x-intercept. X-intercept must be 7, isn't it? Are you just following that? So it's going through close enough to 7. So let's do the math and say it makes sense. So if I put 6/5 times 2 squared is 4 times -1 cubed is -1 times it by -2. So if I do that, so that is going to be 2 times 6 times 4 is 24 times 2 is 48 divided by 5. So let's see 48 divided by 5, 8 times 9. So that's not working because that's going to have an x-intercept more than that. So how about next one? 2 squared times it by -1 times -2. 2 squared is 4. 4 times 2. That's approximately 8. So now we have to think about which one worked. I'm not sure that exactly what that point is. So that's look like a 7. So if that's the case, I'm gonna say, okay, so try again, then I'm gonna use this. Oh, that's not right. So what's going on here? This definitely made a mistake. Oh, there's a third answer. I didn't think about the third answer also. Fourth answer also matching. That works out because 5/6 time, 2 squared is 4. Okay, -1 time. I didn't think about that. So that's worked out because that is going to be 4 times 2 is 8 times 5 is 40. 40 divided by 6. So that's going to be the answer. Oops. Try again. Makes sense? I didn't think of the last one. I was only looking at it. Because 5/6, the x-intercept will be matching for that. Are you just following that online, folks?
Yeah.
Hi. All right. We didn't talk about this one, Jack, because transformation. We're going to go back to transformation. So we did some good review on that. So we're going to talk about transformation. All right. Transformation of polynomial function. So let's explain the value of c is 1. Transformation, vertically translate up by 1 unit. So how that works, each point is going to go by 1 unit. So that is going to go to 1 unit. Here it's going to go to 1 unit. Try to make sure the shape of the curve must be symmetric and goes like that. Make sense? Hello. -2. Vertically translate down by. Are you guys following that, guys?
Yeah.
D value is +2. Horizontally translate. Horizontally translate to the right. So each point will go 2 unit to the right. Make sense? -3. Horizontally translate to the left, isn't it? Hello. Guys, are you guys following that?
Yeah.
Okay, nothing new here. So I'm gonna going back to the next one. So this is we talk about the cubic function. It's pretty easy for A. Value of A here. So Adri, what is the value of A on the first one? 2. Transformation. Vertically stretch by a factor of 2, isn't it? So we're gonna double it. 0, double 0. 1, double 2, 2. So the graph will be a little narrow as it goes like that. Make sense? Hi. Guys. Okay, they're not responding. 1. We're gonna say vertically compress by a factor of 1/2. So this is going to be 0/2 is 0. 1/2 is 0.5, 0.5. The graph is going to be a little wider like that, isn't it? Hello, online folks.
Yeah.
Divya, what will happen here? Can you tell me what will happen to the graph? -2x to the power of 4. You need to do stretch, right? So this is -2. Reflect on the x-axis. Vertically stretch by a factor of 2. All right. I'm not graphing it. You should be able to graph it. We're going to discuss the next guy. Value of K, 2. When this K value is 2, what you're going to do, this is going to be horizontally compressed. Horizontally compressed by a factor of 1/2. Make sense? This one, 1/3. Horizontally stretch. Horizontally stretch by a factor of 3. I just seen that. Hello. When the K value is a different story. Value is greater than 1, we're going to say it's compressed. Value is less than 1, we're going to say stretch. Make sense?
Yeah.
Let me show you how that's look like on the table of values. So this is going to be X value. This is Y value. X is 0, Y is 0, X is 1, Y is 1, X is 2. 2 to the power 4 is 16. Now what will happen? The Y value doesn't change. Y value doesn't change. The only thing is going to change is the location. 0 doesn't change. 1 is going to become at 1/2. So 0, 0. At 1/2, you're going to get 1. So at 1/2 of X, you're going to get 1. You see that? Hello. That's why I see horizontally compressed. Imagine squeezing the graph on that side, isn't it? You're going to go inside. Tivia, are you here?
Yeah.
Okay. Can you describe what's the value of K? What's happening here? What's the story here?
-2.
Okay. What's the translation? What transformation we are deploying?
Horizontally compressed by a factor of -1/2.
No. Horizontally compressed by a factor of 1/2 reflected on the y-axis. This minus is going to be do reflection on the y-axis. Make sense?
Yeah.
Hi. So we're going back to summarize. In summary, AKDC in polynomial function, here's the translation. So when C is greater than 0, vertically translate up. Vertically translate C units up. D. Horizontal translate to the right. By 4 units. I mean D units. Horizontally translate to the left by D unit. A is greater than 1, O is less than -1. Vertically stretch. By a factor of A, isn't it? When A is between -1 to 1, vertically compressed. Reflection on the x-axis. Value of K. When K is greater than 1 or K is less than 1, horizontally compressed. Horizontally compressed. By a factor of 1/2. 1 over K. This is horizontally stretch by a factor of reflect on the y-axis. A summary. You have seen this in grade 10. So that is where we put the foundation for transformation and repeats again, right? Okay, if A and C causes vertical transformation. So A and C will change vertically. And K and D causes horizontal. When applying transformation to the parent function, make sure to apply the transformation represented by A and K first. A and K representing the stretching, and then followed by D and C. So we need to be able to describe transformation in Word. That is what it is. And applying transformation to graph it, we will see some example here using mapping notation. And then next one, how to find the equation by looking at this. So we're going to be going back there. Okay. So let's going back to describe. Describe the transformation that must apply to the graph in each power function to obtain the transform function. Then write the corresponding equation. So let's ask Kilman. Kilman, you're going to tell me the transformation in words.
Okay. Wait, I'm kind of confused. Am I saying for GX or like why is the FX equals X to the power 4 there?
For the G of X, sir.
Okay. So it's a vertical stretch by a factor of vertical stretch by a factor of 2.
Okay, cool. Yeah.
Horizontal compression. No, wait. Horizontal stretch by a factor of 3.
Horizontally compressed stretch, yes. Horizontally stretched by a factor of 3, yeah. Yeah.
Translated 5 units to the left.
Horizontally translate. Five units to the left, yes. I mean, right, sir, is minus here. So that should be okay. To the right. Okay, that's it. Now they want you to write the equation. So g of x is equal to 2 times. So 1/3 x minus 5 to the power of 4. Make sense? Okay, I'm gonna going back to Adhara. Adhara, you're gonna tell me the transformation for the next one. We're gonna say compressed. Okay, what is next? Horizontally compressed, yes. No, you have to switch it. Compressed by a factor of 1/2. Then, no, reflect on the y-axis. That one has a negative. You had to tell that. So y-axis, isn't it? The factor cannot be negative. So, okay, the next one.
Horizontally translate 3 units to the
Correct. Horizontally translate 3 units to the right. Okay. Vertically translate, right? Are you following that? So are you following the transformation? Online folks?
Yeah.
All right. So, applying the transformation to sketch, state the parameters and describe the corresponding transformation. So we know A is equal to 3, K is equal to -2, D is equal to -1, and C is equal to 5. Make sense? So we're going to put some points. -2, -1, 0, 1, 2. So -8, -1, 0, 1, 2 cube is 8. So what is going to be x over k plus d, ay plus c, x over k is -2 plus d -1, ay 3y plus c 5. So how do I get this one? -2 divided by -2 is 1. 1 minus 1, 0. 3 times y minus 3 times 8, -24 plus 5 is going to be -19, isn't it? That make sense? Guys,
Yeah.
okay. So -1/2 minus 1. So there's going to be -1/2. -1, 2. 0. 0 minus 1 minus 1. 0, 5. 1. If I put 1, so -1.5. 1, 8. If I put 2, 2 divided by -2, -1, -1, -2. And it's going to be 8 times 3, 24, 29. Does it make sense? Hello.
Yeah.
All right. So let me graph that. So first one, 0, -19. I can't really fit it. So somewhere here. So that's going by 16. I don't know what the scale they're using it by going by 4. Okay, -19. Then -1/2, 2. And then -1, 5. -1, 5. I don't know whether -1/2, 2. -1, 5. 4. So this is 6. So it's going to be -1, 5. Okay. -1.5, 8. Okay. Then -2, 29. I can't really plot that. So now we're gonna going back to see what's really happening here. So you're gonna see that this is gonna be, if I plot that -2, 29 somewhere far away, somewhere here. So you can see that if I do the nitro, it's gonna go like this.
Circling the one.
Yes, sir. So yeah, it should be inside. Just the only thing is just careful under this chair there. And so it's come like that, go through -19. Are you seeing the picture? Hello. Guys. Did you find it, sir? Inside. Yeah, go inside, yeah. Divya and
Yeah,
Gilbert. Are you guys following how the graph look like?
yeah.
Yeah.
Okay. So now we need to talking about same thing to graph. So a value. So Adre, what is the a value of the next function? -1. What is the k value on this function?
Oh. What do we
Correct. What is the d value? No, it is not. This is tricky. You have to common factor the 1/3. So this is going to be x plus 6 to the. So we have to be really careful. If they in front of the x, if you don't have a value other than 1, you had a common factor. D value is -6. What's the c value? So I'm not really worried about it. You are expert on graphing this. You have learned how to do the graphing from grade 11. So you should be able to sketch it. Right. So we will choose some point. -2 is going to be -16. -1 is going to be 1. 0 is going to 0. 1 is going to be 1. 2 is going to be 16. X over k. So x over k is 1/3, 3x plus d minus 6. Ay minus y minus 1. So -2. 3 times -2 is going to be -6, -6, -12. -16, -1, -17. So if we do -1, -3, -6, -9, -2, 0, -6, 1, so it's going to be -2 again. And then something I didn't do correct. 0 is going to be 0. So if I do a 0, 0 minus 6 minus 6, 0 minus 1. If I do 1, 3 minus 6 minus 3. If I do 1 minus 2. If I do 2, 6, 0. If I do 16, minus 16 minus 1 minus 17. Are you just following that? The points we generated?
Yeah.
You know how to plot that, so it's not my business to plot it. You should be an expert on that. All right. Symmetric and polynomial function. And then what's happening after symmetry? Okay. So now let's going back to this, guys. Sometime you'll be provided with the transformation, so you should be able to find out what should be the equation look like. So the best way to find out in the polynomial function, there's only specific transformation that we're going to be really worried about it. So first thing, you're going to looking at where does the turning points move to. So let's going back to where does the turning point move to. So originally 0, 0. So right now he came back to -3, I'm going back to -2. So you can see that I can see that it's -5, isn't it? Hello, guys.
Hello.
Are you guys seeing that? What happened to that point?
Yeah.
0, 0. It came to -3, -5. So when it's come to this transformation, there's only specific transformation we're going to be worried about. So let me going back to the two transformation. Just give me a moment. What? I need to check the two things that I need to talk about.
Okay, so
Yeah. Okay. So the transformation, we will worry about it. We're going to looking at the D and the C. So the D value, you can see that it's moved to the right by 5 units. I mean left, so -5. C values came down 3 units. So original function y is equal to x to the power of 4 is going to be transformed into x plus 5 to the power of 4 minus 3. Are you following that? Hello.
Yeah.
Okay. So we're gonna going back to the next one. The 0 move here. So D value is 5. D value is 5. C value is 0 because the graph doesn't move up or down. But something you can see that the graph has been reflected. You can see that it's completely different in behavior. So A must be -1. So it's a cubic function. -1, x plus 5 to the power of 3. There's no C value because C value is 0. I think that I made a mistake. It should be -5 because if your D value is positive. How do you see the picture?
Yeah.
All right, so that's being set. We're going to be on the last part here. Symmetry in polynomial function, which I talked about before, what we're going to be revisit. So symmetry in polynomial. There's a vertical line over which polynomial remain unchanged even reflected. And there's, so this is called the line symmetry. So this is called the line symmetry. There's a vertical line over which polynomial remain unchanged when reflected. point symmetry. Point symmetry. There's a point about which the polynomial function remains unchanged when you rotate it by 180. So line symmetry, example of the line symmetry is simply parabola. So if you reflect this point, you got this point in this side. The y value doesn't change. And then point symmetry, there's a point about the polynomial remain unchanged when rotated by 180 degree. So if you're just going to be rotated by 180 degree, if you're going to rotate this one point by 180 degree, there's a point about the polynomial remain unchanged when rotated by 180. You're going to be going back to the same point again by rotating by 180 degree. So how we talk about this in the beginning, but we're going to going back to some rules here. A polynomial function of even or odd degree is not necessary and even an odd function. So this is very important. Most people confuse with the degree versus the even and odd function. The degree, the highest exponent, but the even and odd function determined by the symmetry. It's determined by the symmetry. So an even degree polynomial function is an even function if line symmetry over the line. The exponent of each term is even, but you can have a constant. Point symmetry about the origin. The exponent of each term must be odd, no constant term. So you can see how that picture look like. For the points, the line symmetry, you got f of x. F of negative of x is also produce the same y point. So if you look at here, f at 1, 2 plus 3 minus 2, which is going to be 3. F at negative 1, 2 times negative 1 to the power of 4 plus 3 times negative 1 squared minus 2, which is going to be 2 plus 3 minus 2 again 3. But let's look at this. F at 1, 2 plus 3, which is 5. F at negative 1, negative 2, negative 3 is negative 5. So what does tell? F at 1 is equal to negative of f at negative 1. So this is point symmetry. Point symmetry. Or we can say it's odd function. Odd. And this is an even function. Most common confusion is even functions are not even degree functions. Or not all the even degree functions need to be even function. Are you seeing that picture? Hello?
Yeah.
Hi. So the degree versus even function. Even degree versus even function is different concept. So if you guys understand it, we're going to going back to C. Identify each function as even function, odd function, or neither, and explain. So we're going to going back to the technique we have been utilizing it. So let's going back to who is here. Let's start from Divya. Divya, it's an even function or odd function or neither. What do you think? I think
Odd, no, even function.
it's an odd function. Let's see why. The exponent of each term is odd. Look at that, it's odd, isn't it?
Yeah.
It's an odd function, but let's prove it differently. The way to prove if f of negative of x is negative of f of x is an odd function. Let's do that. Your f of x is x cubed minus 4x. Let me do f of negative of x. Negative x cubed minus 4 times negative of x, which is negative x cubed plus 4x. Let me common factor minus out x cubed minus 4x, which is at f of x. We were able to prove here f of negative of x is negative of f of x. So that's an odd function. Make sense? Hi, are you guys following that?
Yeah.
Okay. Let's go back to other right. Odd function or even function or neither? How come, lady? This is odd, but there is a constant term. If you have a constant term and then the rest is odd, it's neither. You have to mark all odd, even, all even, it's possible to have a constant. So let's going back to Kilman. What do you think, sir?
Even.
Even exponent, constant term, it is even. Kevin, D. Neither, yes. Because you have a mixture of degree here. Divya, E. Divya,
Neither.
yes. Okay. So you guys going to have, I'm gonna do some examples so you can do that. Choose then apply. No symmetry, point symmetry, line symmetry, odd function, even function. First of all, it is not an even function, but we're gonna see it has a symmetry. So how to check for the symmetry? We had to looking for some specific point that we are talking about. You got 1 comma -3 point, but same point is appearing -1 comma 3. Did you guys see that?
Yeah.
So that satisfies f of negative of x is negative of f of x. So let's prove f of 1 is -3. F of -1, negative of f of x, because negative of 3. Make sense? Are you just following that? So first point I say, we need to prove this. F at 1 is -3. F of -1, I got +3, which is equal to negative of f of 1, isn't it? Because negative of 1 is -3, which is +3. That tells point symmetry. When you have a point symmetry, you can guarantee it's an odd function, isn't it? Makes sense? No symmetry, 100% here. We can see that clearly. So you guys got some bunch of questions to work with. So can you guys do C, D, E, F, G? I'll be back. Circle the one that I apply. Let's see how would you guys play with that. All right. Look at the strategies I show you.
Let's see.
Tillman, what did you get for C?
Neither. There's no symmetry.
That's right. Because mixture of exponents. Right. D, yeah.
I got weight symmetry.
What? Point symmetry. Point symmetry only for odd degree. So to have a point symmetry, you have to have an odd degree here. So you got a 6. So it's an even function with line symmetry. All the exponents are even with the constant is going to be even function with line symmetry. So let's go back to Divya. What do you think, Divya? Next one.
Line symmetry.
It's line symmetry, yeah. You can see that the whole thing is overlap, so it's an even function. What do you think about next one, sir? Yeah, line symmetry. All right, going back to Adurai. What do you think the next one? Odd function with point symmetry. Why it's odd function? You see all the exponents are odd, isn't it? Okay. Now, without graphing, determine each polynomial function line symmetry about the y-axis, point symmetry about the origin, or neither. You know what to do. You have mastered that, so I'm not really worried about that.
Wait, you can have odd functions with line symmetry, right?
No, sir. Odd function cannot have line symmetry.
Okay.
You can only have odd function with the point symmetry, even function with the line symmetry.
Okay.
Right? Okay. Yeah. Yeah, go for it, sir. Example 3. What do you think? Even function or odd function? Are they? What kind of symmetry there?
Oh, this is oh, yeah.
Even function. So it is going to have a line symmetry. Okay. Kilman, what do you think next answer?
It's none because like the exponents are odd and then there's a constant. Oh no, there
Where's
isn't
the
a constant. Wait. It's just odd.
So it's going to be point symmetry about the origin. Make sense?
Yeah.
Divya.
Neither.
Correct. All right. So you guys going to answer the next question by yourself. Connecting from throughout the unit. All right, so I'm gonna be assign you guys some more tasks to do it. So let's discuss that. Learning something is coming on the way. Done. So let's do the least possible degree. This is what? This one, interval where fx is less than 0. So where the function is negative. In which interval? In which interval function is negative? All right, so let's going back to x-intercept. Gilman, what do you say the x-intercepts are?
Negative
sorry.
2, 0, and 2.
-2, 0, and 2. Number of turning points, sir.
4,
What is the least possible degree?
5.
This is 2, this is 1, this is 2, is right. And then any symmetry present.
No.
How come?
I'm not
So-
sure. I just
This is 1, this is -3. You have a point -1 comma 3, and then you have a point 1 comma -3, isn't it?
yeah.
So that's going to be point symmetry.
Okay.
Okay, now we're gonna go back to the last one, in which interval it's negative. So let me help you guys to find that. So you can see that graph started to get a negative starting from 0 and go all the way up to positive infinity, isn't it? Are you seeing that? Start
Yeah.
at 0, all okay. All right, all right. I do have a review sheet. The only problem, my English, I'm running out of ink. I know, I'm not. It said you have to put a paper clip for this. I don't have a space, so I need to buy it. So we're gonna going back to find up some review here on this unit. But I hate it hasn't answered. So it's okay. There we go. Let me just give you that sheet. Right, here we go. So we're gonna going back to some review on what we have done so far. A lot of things we talk about it, a lot of things in this unit. So let's do some math in here. All right. Polynomial function. I gave these guys the worksheet, so workbook. Okay, so we're gonna be doing some practice. You're gonna do the okay in textbook question. You can go back to 3.3. You can go back to 3.3, and you can go to 3.4, 3.3, 3.4, and then you see it's a mid-chapter review after that, and followed by the big unit. We're gonna come back dividing polynomial. So, but let's going back to some practice on what we have done so far to make sure you understand the material. So insert, NEM, recent. All right, here we go. So let's do some practice in here. Pretty straightforward workbook 1. To tell which one of the polynomial function, I'm not really worried about question number 1. Question number 2, pretty straightforward, I believe, but let's do a specific one. So, Divya, what is the degree and what is the leading coefficient?
The degree is 4. And the leading coefficient is
I'm talking about this question with a little arrow mark pointing towards. What is the degree and what's the leading coefficient?
4.
Okay, what's the leading coefficient?
-1.
So both of them are not correct. The degree is 3. And the leading coefficient -1/4. Make sense? Are you following that?
Yeah.
Okay. All right. Next one. What is the degree? What's the leading coefficient? Degree is 0. So what's the leading coefficient? That's the only term we have. So that's a leading coefficient there. Okay. Now, pretty straightforward to fill out the table. I'm not really worried about the table. So, but we're going to be looking at this one quickly. Hillman, even or degree, sir? The one I green.
Odd.
Sign of the leading coefficient, positive or negative?
I'm not sure.
It should be negative. So it's going back to quadrant 2 to quadrant 4. So odd degree going that way. Sign of the leading coefficient must be negative. Domain and range, we talk about it, polynomial function with the odd degree. X belong to real for the domain. Y belong to real for the range. No restriction apply. Symmetry, point symmetry, you can clearly see that. In behavior, when X goes to positive infinity, Y goes to negative infinity. When X goes to negative infinity, Y goes to positive infinity. Make sense?
Wait, so I have a
Hello?
question.
Yes, sir.
See the one above it?
What?
The graph above it?
Yeah,
Would that would the sign of the leading coefficient for that be positive or is that also negative?
positive, because there's a, you can see that anything that go from quadrant 2 to quadrant 2 to quadrant 4 or quadrant 3 to quadrant 1 must be
Yeah.
odd degree polynomial. Now, when
Okay.
it's go from
Okay.
quadrant 3 to 1, the leading coefficient must be positive. Make sense?
Yeah.
Okay, we need to match this. We did some question like that. I'm going to give you guys a little time. So can you just quickly do that, please? Quadrant behavior to match it. Question number 4. Question number 4 is to match with the quadrant behavior. All right. So, done. Almost done.
Yeah.
I showed you the strategy last time. You have to have 4 graphs right in front of you to match it, right? That is how it works. 4 graph in front of you to match. All right, so shouldn't take that long. So let's start with othering. Which one go from Q3 to Q1? Y is equal to 5x. You got it right, yes?
This is like 4x to the power.
Work out. Leading coefficient, positive, and odd degree, yes. So Kilman, Q2 to Q4, sir.
It's negative x to the power 3 and negative 0.1 x to the power 11.
Negative x to the power of 3 won't go, man. You had it. Oh, yeah, you're right. Okay, the negative x to the power of 3, yeah.
And negative 0.1 x to the power 11.
Negative 0.1 x to the power 11, okay. Q2 to Q1, sir.
Y is equal to 3/7 x squared.
Yeah,
Y is equal to 2x to the power 4.
here, yeah. Q3 to Q4. If you're speaking, I'm not hearing, so you might be muted. Tivia. Adre.
That's like a negative x to the power.
Negative x to the power of 6. Okay, sure.
X to the power.
Correct. So I'm gonna be post this worksheet in addition to the textbook question for you too. So you should be able to do everything up to 3.4 is your homework because we have done it. So that's being said, I'm gonna be at this for the homework to practice. Okay, polynomial. Okay, I'm gonna say August 17 lesson homework. Upload file. We're gonna going back to algebra part next class. And that is going to be, I don't know what I want to call this. Okay, let's call this homework. All right, so you can do everything up to mid-chapter review on the textbook. So in addition to the textbook problem, you can do from chapter 3.1 to 3.4 plus the mid-chapter review. If you really spend time on doing that, you can sleep in the class at school when this unit is being taught, right? Because next week I should be able to finish the chapter 3. That's one of the biggest unit, huge unit. Then we will go back to the rational function. I want to see, sir, how did you do the homework on buying and on back? What happened? What?
That was miscue. I think it was folding.
Pretty good. See that? It's far better than just writing on a piece of paper, right? Okay. So I will say that keep this notebook just for your homework or taking the notes, right? And then you will have a handout. So that's easy to go back to do some review again, right? Okay. That's for you guys today. I will see you next week. Don't miss the class next week. I record the meeting for some of them that didn't show up. Okay, I don't take a break unless then I'm sick. I can't really teach. All right, Divya.